Welcome to another video in the series Process Automation with Netfabb. This is level 2, out-of-the-box Lua scripts. Let's have a look at Lua for all of those who have not yet had anything to do with it. Lua is a lightweight scripting language that is fully implemented in Netfabb. A part of the regular Lua syntax, we have added additional features and functions that allow you to call and link nearly all functions of Netfabb. How such a script can look like is shown here on the right. In this example script, a component is imported, scaled or orientated, placed and stored in a folder. Afterwards, if you prefer, Netfabb can also close itself after finishing the script. Before we get too complex and too specific as well, I would like to take a step back. Netfabb comes out of the box with more than 30 sample scripts. All of these scripts are not technology specific and not machine specific as well, and they do cover the entire build job preparation aspect. I have listed a few examples right here. Just like that, you can use these as a great starting point for your own automation projects. So, how do you use these scripts? Before we get there, let me first show you how they are stored. They are usually located in the Netfabb installation directory, and for the better handling, we recommend an editor like Notepad++ to simplify the general understanding and have a better overview. In the example scripts, we usually see very well documented what the different parts of the code do. Here, the green areas, for example, are comments that our developers have added for better clarity. The script we just looked at automates the labeling of the parts. All right, let's think of the following situation. We now have different impeller variants in our build shop that are all prepared and supported. And in order to identify the parts later on, we want to label them. We would either have to do this individually for all parts or use the list label function up front. However, this function focuses on a single part geometry and would have to be used 3 different times in a row because we have 3 different geometries in our build plate. So let's see if the script that we have just seen could be any useful for us. In our case, we go to the Lua script menu, we upload a script from the folder that we've just checked, and after picking the right script, we can assign a different name if you like. We can use the built-in debugger to check if everything is all right. And as soon as we are finished, we can save and execute the script. As we can see, the label of the component is projected wildly and uncontrolled over the entire part. So this is not really working for us. That means we should take a closer look on how the script actually works. The script itself basically consists of single topic blocks. The first one defines the position of the label for each direction. So we want to define that the label is applied from the left side onto the parts. Depending on the bounding box, the label should be positioned on the bottom side close to its minimum value. In the last part of the script, we then select our defined direction. So we take, of course, the left side that we have specified, and we define if the label is going into the part or if it is being added on the outside of it. Furthermore, we can also describe how the part should actually be labeled. Now, we only have to re-import the optimized script and check if our adjustments were successful. After uploading and executing the script, we can see that all of our parts have been labeled successfully as the label has been applied coming from the left side and it has been added right next to the bottom area where we wanted our label to appear. So this was a very easy way of how a little optimization can directly improve the user experience on part labeling. Another example script deals with the entire laser melting workflow, with orientation, support, and process simulation as well. Here, all of these points take place one after the other. First, the part is oriented. The 4 best orientations are used. Best in terms of the orientation with the lowest height, with the lowest support volume, lowest support area, and so on. Afterwards, the part is supported by a support script that is specified in the script, and finally simulated with Netfabb simulation using a predefined PRM that has been selected in the script as well. The simulation is running in the background. We can see that right here, the parts and the simulation results are saved in the folder that is specified by the script. In this folder, we are getting all of our results and all of our geometries saved so that we have all the information as we need it, where we need it right away. This is a very good example that shows how even complex process chains can be simplified and standardized. In summary, we can say that the large number of example scripts provide a very good starting point for your own automation project. Lua, as we have seen, it makes it very easy to find an introduction to programming. Also, an integrated debugger can help at this point and provide valuable assistance. Also important, the scripts are technology independent, which means that you may find many starting points for a variety of different 3D printing technologies. So, this was level 2 of our video series, Process Automation with Netfabb. Thanks for watching, and I hope to see you around for the next video.